So we're going to move on to our next speak. So it will be paper ID 64. 64. And yeah, he will be presented online. And the title is a knowledge graph for automatic construction workers safety violation identification. Is Mr. Yifan Zhu from University of Hong Kong. So the floor is yours. Thank you.
Okay. Here. Thank you so much. Here's my presentation about a knowledge graph for automatic construction workers safety violation identification. Yes. Nowadays, the construction safety is crucial for the construction industry, and workers' unsafe behavior is one of the main causes to the accident. So timely identification of workers' unsafe behavior is crucial for safety. And currently, in automatic surveillance field, researchers and companies mainly use the artificial intelligence and AI and system technologies like the surveillance camera or GPS to detect the safety violations. For example, in business, the company just always focus on the personal protective equipment, the PPE, and to detect the weather gathering, like the PPE detection product. It focused on the safety equipment detection, like the hard hat. And in research, the researchers always combine the multiple data and methods to recognize workers' unsafe behavior. Like Xiaowei's research just used the object detection method and spatial relationship to recognize workers' unsafe behavior. Also, they have proposed these several applications, but this current application just focus on the certain safety rules and hardcode them for AI, which limited the explainability. So it is necessary to propose a new knowledge implementation for AI to timely understand the safety-related knowledge. So to solve this issue, we face some challenges. The first is how to represent this knowledge and to make the AI understand. And second is the hard coding knowledge is labor intensive. So how to construct the knowledge representation automatically and to reduce labor cost. And the corresponding objective is to design a suitable knowledge implementation and to offer an automatic construction framework. So in this research, we propose a construction framework. It contains two parts. The first is a new knowledge graph representation. Second is the corresponding automatic construction framework to generate this knowledge graph. For the knowledge graph, it has contained two main components. The first is a new knowledge graph to store safety rules and to make the AI understand what is rule about and how to use the rule to identify. Second is the association knowledge graph to store the safety knowledge and to make the identification to become more precisely. And for the rule knowledge graph, it is composed of a set of safety rules with two parts, the requirement and condition. Besides, each rule always concentrate on one of the safety aspects. And in rule knowledge graph, it is divided into 4 layers to represent the rule structures. And first and second layer is to represent the triplets. Besides, in the third layer, it represents the logic education of the triplet. And the node type in this layer has 2 parts. For the first time node, logic node to represent logic education with 3 times and, or, and not. And means that the all belonging triplet should be followed. And all means that at least one triplet belonging to this node should be followed. And no means no triplets. For the second part, the part node, it means that which triplets belong to requirement part or condition part within the REQ and the CON node. And for the first layer, the statement layer is the statement node to define which requirement or condition parts belong to one rule. And so for the association knowledge graph, it is composed of a set of triplets with 2 fixed relations, similar and subclass of. Similar means the 2 entities inside triplet is similar. Subclass of means that subject is the subclass concept to the object. So for the third part of the construction framework, it is constructed. It is still contain 2 parts. The first is to construct the knowledge graph, We first will send a synthesis time safety rule into an automatic instruction model. Then it will output and set up the half triplet. Then we send this half triplet into an automatic construction program to construct the rule knowledge graph automatically. And for the automatic instruction model, we use the instruction model proposed by the Weiss research. And then we just cut, and for the output of the triplet, we cut the triplet into two parts. For the first half triplet and second half triplet. Because if we use a fixed relation to link with the subject or object, it will restrict the feasibility of the representation and cannot suit the proposed structure of our knowledge graph. Besides, the relation in the half triplet always contains several data. And for example, in this relation in this triplet always contain the connection type and the object type and part node and logic node. And for the automatic construction program, it contains 4 main steps to construct the rule knowledge graph. We are first to associate the entities attribute, then to combine two related half triplet to combine new triplet, then to make up some triplet that without the first half triplet. Finally, we just construct the logical and statement layer based on the relations. Then finally, we just use 4 steps to construct the rule knowledge graph. And also for the association knowledge graph, we first to find entity and related to the construction safety and the relations with the similar or subclass meaning in the subject knowledge graph. And then we just observe the entity in the rule knowledge graph to find which entity has the similar or subclass meaning with each other. Finally, we just to combine these two data to construct the association knowledge graph. So to verify our framework, we just did a case study, and an experiment that's combined has 2 parts. The first, we just to construct the knowledge graph. We first to connect nearly about 97 specification that related to the construction safety, and then use the several pre-processing approach like the manual instruction to connect nearly about 1,000 safety rules. After that, we just use the graph list tool to annotate the safety rule and obtain an annotated file, and then use this annotated file to construct the rule knowledge graph and store it into a Neo4j. Then we use the data from the OnSync to construct the association knowledge graph, and finally, we have to combine these 2 knowledge graphs to construct the finished knowledge graph. And for the second part, we just train an automatic instruction model. We first use the annotated file to ask the training data set, and then to train this instruction model. And finally, we just obtain this finished model with the overall F1 value reach about 67%. And the performance of this model is shown in the right table. We can see that we just use the base color to indicate which triplet with the different safety aspect. Based on the observed triplet, we just divide the result based on the type of connection node and the triplet function to 4 times. The operate, position, predict, and attribute. And the conclusion of this 4 times is shown in this table. And you can see that the performance of type predict type and attribute type is the weakest, and the operate type have the best performance. Reality is that the some half triplet with a fixed text structure has a good performance, and the operate and the position just occupy most of the half triplet with a fixed text structure, and the fixed text structure include this about demonstrating the PPE wear situation and the weathering, the attribute, and the person, and some places. Then, finally, in this research, which has proposed a new knowledge representation to make the AI understand the safety knowledge and establish a new corresponding construction framework. And to verify this framework, we just build a knowledge graph with nearly about 1,200 safety rules and train an instruction model. The F1 value performance of this model is reached about 67%. To the contribution, this framework can assist AI to automatically to do the safety identification, and the manager can select the identification range by themselves and to suit a construction site. Then besides, This framework is good for the automatic construction, and it can to generate economic benefit by reducing the labor cost. Also, we propose this framework. Several limitations have to be overcome. First, the extraction model still to improve the performance, and besides, we should collect more related rule. And nowadays, only 1,000 rule is not enough. And finally, this framework cannot transfer the video into a textual description, and this framework do not be verified in the reality. So in the future, first we should offer a more precisely automatic instruction model, and besides, we should collect more related safety rule and to construct the knowledge graph. And then we should use this knowledge graph to integrate with a practical application and do the experiment on the construction site to verify its feasibility. So that's all my presentation. Thank you so much.
Thank you. Any questions from the auditorium? No question from the auditorium. So I have one question from the Zoom. Yeah, I can see one question from the Zoom. Can go ahead.
Yeah. Could you let me see?
Oh, can unmute.
How to unmute?
Okay. Well, thank you. I was able to unmute now, but I could not turn on my camera. I'm not allowed.
Okay.
So thank you, Yifan, for this presentation. I have a quick question related to the construction of these rules in the knowledge base or the knowledge graph. Have you considered the different names or different terms that express similar meaning, right? For example, you have showed the example of safety belt, but we may call it safety harness, or there can be different expressions. So have you considered that, or not yet?
Yes, thank you for your thank you for your questions. In your question is in my understanding, the question is mean by how to understand the object meaning in the based on the difference based on the same description by the different times. In this way, we just
correct.
Yes. In this rule knowledge graph, we first to use the different object type to describe the entities attribute. For example, you can see that in this knowledge graph, I can show you my backup. In this way, you can show I have list content node type and the connection node type. We use the content node type, the person, work, object, location, and the environment to describe the entity's attribute about which type is about. For example, we use the person type to describe the entity about role and provision, and use the work type to describe the behavior or action entity. And besides, in this way, if we want to describe the more detail about the entity's attribute we can use another attribute to describe the entities. And for example, we use if we wanted to describe the environment, the web level, we can use this entity to describe. And here's he can show that we can use this three attribute to describe the wind level including the property, value, and the unit. Like property means that the environmental range section, and the value means the threshold, and the unit means the unit. Besides, if we wanted to describe more detail about the difference between some working space, we can use the belong to relation to describe. It is not shown in the due to the time description. We do not show in the PowerPoint, and you can use the correlation to describe these two entities to describe the working space and to describe difference. So that's more of my reply. Thank you so much.
Okay, thank you, Yifan. So if I understand you correctly, you are saying the safety belt belongs to safety harness, for example, right?
Yes.
Okay, thank you.
Okay, thank you. Once again, thanks you for the presentation again.